Okay, let's take a look at our last couple of examples here. And I want to use everything that we know so far. For example, I'm giving you a fourth degree polynomial here. And I'm going to say that it passes through a point of 1, 2. But here are the zeros. So no graphs, no nothing, just a straight out answer. So you know that x equals to minus 1. You know that x equals to 0, x equals to 3 over 2, and x equals to 2. Now, make them into those nice little binomials that you're used to. Bring the 1 over. So you got x plus 1. There's your first factor. There's an x value here. Then look at this. You got 3 over 2. So you got to play around with this first. Remember, you got to multiply both sides by 2 to give you 2x equals to 3. Bring the 3 over. You got 2x minus 3. Beautiful. So there's your 2x minus 3. And then our last but not least is this guy out here, which of course is going to be x minus 2. Beautiful. So let's rewrite this. But the thing is, it's passing through a point 1, 2. Uh-oh, that must mean that you might have a c value up front. That value which tells you how much you've stretched this polynomial by. Interesting. So we're going to go out and do that right now. So y equals to a c value goes up front. There's our x plus 1. There's our x, our 2x minus 3, and finally our x minus 2. Now I need a little bit more room. Let's just clear this out. Our x minus 2. There we go. There's all the factors that we determined from the zeros. We put the c value up front. Now, remember that this point here, right here, is an x, y point. So let's just substitute it in. All right, so our y is 2. Our c value is still there. Our x is 1. 1 plus 1. There's another 1. Everywhere there's an x, we're going to put in a 1. Look at this. Look at this. This becomes just a simple exercise in solving for c. Wow, is that ever neat? 1 plus 1 is 2. So we got c times 2. That's still 1. 2 times 1 is 2 minus 3 is minus 1. And 1 minus 2 is another minus 1. This all has to equal to 2. So check this out. 2 times 1 is 2 times a minus 1 is minus 2 times a minus 1 is back to being positive 2. You have 2 equals to, oh, sorry about the crack there, equals to 2c. Divide by 2, c equals to 1. Oh, how nice. Our c value is actually 1. So there's this in factored form. Now, if you read the rest of the questions, one thing that I didn't tell you about in this question is that, yes, they wanted in factored form, but remember, it wanted only integrals, which means only integers. That's why we had to take this 3 over 2 and actually figure that out to be that. Well, that's simple enough to do, isn't it? Yeah, so let's make it a little bit more challenging. Let's take a look at the last example of this unit. Interesting, interesting, interesting. Watch this. This is a polynomial equation that has the following 3 roots. First off, it has a minus 2 with a multiplicity of 1, which means it's just going to cut the axis in one spot, just like we're used to. So let's take this guy right now and say this is an x plus 2 factor, right? Now, we've got that 1/3. Uh-oh. Yeah, exactly. X equals to 1/3, which means times both sides by 3, leaving you 3x equals to 1. Bring the 1 over. This is 3x minus 1. There's our other factor. And it has a multiplicity of 2. Uh-oh. So that's going to be squared. Wow, neat. And then finally, minus 1 is a root with a multiplicity of 3. Oh, okay, well, that's easy enough because that means x equals to 1. Bring it over. X minus 1 has a multiplicity of 3. There we go. X minus 1 has a multiplicity of 3. Now, the only problem is here, folks, is this. This graph has a y-intercept of 2/3. Remember what y-intercept means. That means the x value is 0, the y is 2/3. Aha! So do we have some kind of scale factor that we have to worry about? Probably. Yeah. Okay. So I'm going to rewrite everything down here because we're going to need some room for this. Okay. So first things first. Oh, just a little bit higher so that we can see everything. Okay. So this is an x. This is a y. So my y is 2/3 equaling to c times, remember, it's got to have some stretch factor out there, okay? X plus 2, multiplicity of 1, 3x minus 1, multiplicity of 2, and x minus 1, right? Multiplicity of 3. Okay, put my x values in. My x values are 0. Oh, that's easy. That's a 0. That's now a 0, okay? And that's a 0. So look what you got. Oh, this is actually not that bad. This is 2/3 equaling to c. That's going to be 2. That's going to be 3 times 0, which is 0 minus 1 squared. Don't forget this here. And that's going to be minus 1 cubed. Oh, okay. Not so bad. Okay, minus 1 squared is going to be 1. So 2 times 1 is now just plain old 2. That's these guys put together. Minus 1 cubed is going to be minus 1. That's going to be times your c value equals to 2/3. Oh, ho, 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 ho. Interesting. Okay, so 2 times minus 1 is going to be minus 2. C has to equal to that 2/3. Oh, okay. Well, that's easy enough to do. Get rid of the minus 2 by dividing by minus 2 both sides. So divide by minus 2. That cancels out. C equals to 2/3 divided by minus 2, which you know from fractions is the same as saying 2/3 times the reciprocal, which is 1 over 2. The 2's cancel out, giving you a C value of minus 1/3. Look at that. So all you have to do is remember that C value is 1/3. Go back over to here, okay? Write everything out like you had before. Well, where is it? Oh, there it is. So our C value is 1/3. So this, in fact, has minus 1/3. Was it minus 1/3? Yes. Whew. Okay, good thing I checked. Minus 1/3, x plus 2, 3x minus 1. There's a multiplicity of 2. And finally, x minus 1 with a multiplicity of 3. Oh my goodness, what a neat question and what a great way to end this unit.